right, convert 1 comma radical 3 comma 2 into cylindrical and spherical. Now this time let's try to use formulas to figure this out. Okay. Solution. First, if you have 1 comma radical 3, if it's 1 and radical 3, and this is the point that you're trying to represent in polar coordinates. What's this distance? R is square root of 1 squared plus radical 3 squared, so it's square root of 4, which is 2, right? So that length is 2. Now, can you, just by looking at this graph, can you tell what this angle is? 60, right? It's the ratio of this and that being 1 and radical 3, we recognize that as special ratios. So it must be one of the special angles, and since this is kind of big, you know, it must be the 60-degree one. Okay. Therefore, in cylindrical, it's easy. What is it? You say R, which is 2, and you have to write your angles in radians. So what do you write? Pi over 3, and your height is 2. So when you go from rectangular to cylindrical, the z value doesn't change. You use the same z, you only change the r and the angle. Okay? So that's what you get in a cylindrical. So that was easy. And then to get to the spherical, we already know what to use for theta. That it uses the same theta, so we're just going to use pi over 3. Now to get the rho is the distance from the origin to this thing, right? So let's calculate the rho. Rho is square root of 1 squared plus radical 3 squared plus 2 squared, which is square root of 8, and that's 2 radical 2. That's your rho. That's the distance. All right? Okay, now to get the phi, angle phi, I can never remember the formula for phi, so I usually just draw this picture. If this is the z-axis, so this length is z, the angle from the z-axis is phi, and the distance from the origin to that point is what we call rho, and the distance from the point to the z-axis is what we call r. So you get this right triangle. And if you say it out loud just like what I just did, it's easy to remember. It kind of makes sense. Okay, I have this, and I see that tangent of phi is what? Tangent of phi is r over z, which is 2 over 2. Oh, okay, so it's 1. So phi must be pi over 4. It must be 45 degrees. Right? So now we have the answer that it must be 2 radical 2 pi over 3 and pi over 4. And it's spherical. Okay. Now, let me just add one more thing. You could have used this, or since I already know the rho, you can also use phi as cosine inverse of adjacent over hypotenuse, z over rho, in which case is 2 over 2 radical 2. And you get the same answer. If you think that's easier, you would want to use that. Okay. Now, a final remark. You will be using spherical coordinates a lot when you do this in your electromagnetics class. Okay. Some of you have to take that. And it turns out that for engineers, they somehow have a strange convention of calling what we call theta as phi and calling phi as theta. I don't know why they do that, because that causes confusion. Then going from cylindrical and to spherical causes a huge confusion. But that seems to be the way that people do it in the engineering courses. So that's something to keep in mind when you see spherical coordinates in engineering textbooks, because in most cases they have the symbol switched. What we call theta, they call phi. What we call phi, they call theta.